We're going to begin the second worksheet, and you'll notice that this front side is actually very similar to what we were doing. We've got a recap of mole to mole, we've got a mass to mole, and then we've got a mole to mass. So there's really nothing new on this side of the worksheet other than you've got to write the whole balanced chemical equation. So we're going to kind of go quickly through this, and then we'll work on the back side, which is more mass to mass, which involves additional steps. So for this first one, iron 3 nitrate solution, iron is 3 plus, nitrate's minus 1. So we have FeNO3 3 reacts with lithium hydroxide. Both of those have a 1 charge, so LiOH, to produce. Now they're telling you what the products are, but if they had told you that this was just double displacement, you would know that you would switch and the cation from the front would bond with the anion of the last. But they tell you that it makes FeOH3 plus LiNO3. So of course we need to get that balanced. 3 LiOHs and 3 LiNO3s is your balanced chemical equation. So in B and C, they start you with moles of lithium nitrate. No, they start you with 3 moles of iron 3 nitrate, and they want to know how much lithium nitrate is produced. So again, this is mole to mole, so if you want to pause and work it out, your final answer is 9 moles of LiNO3. For part C, they want to know how many moles of lithium hydroxide are needed to produce 6.3 moles of iron 3 hydroxide. So if you want to pause and try that one, you end up with 19 moles of LiOH. So those are just mole to mole like we did before. Alright, then for mass to mole, we've got an additional step, and we just need to include the molar mass. And so sodium reacts with chlorine, so sodium is a free element, doesn't have a charge on it, it's not a diatomic. Reacts with chlorine gas, which is a diatomic, to produce sodium chloride, so Na plus Cl minus makes NaCl, and then we balance it with a 2 there and a 2 there. So there's our balanced chemical equation. They ask how many grams of chlorine are needed if 4 moles of sodium react. Well, we're given moles of sodium. We've got to get to moles of chlorine. Their relationship is 2 to 1. And then they want to know grams of chlorine, and so we need to use the molar mass of chlorine, which would be 71. So your final answer on that one with 2 sig figs is 140 grams of Cl2. And in part C, how many grams of each reactant? So we have 2 reactants, so we need to solve for both, would be needed to produce 2 moles of sodium chloride. So your answers there are 46 grams of Na and 71 grams of Cl2. And then the last kind of recap question, lead 2 nitrate and sodium iodide react to form sodium nitrate and lead 2 iodide. So these are your products, and they're asking, well, which one's the precipitate? And if you remember your solubility rules, we're looking for the thing that is insoluble, which means it'll be a solid in solution, and it literally falls out of solution and forms the solid. So if you look at your solubility rules, we remember that anything with sodium is soluble, anything with nitrate is soluble. So this one's definitely going to be AQ, which leaves that one to be the solid. So the precipitate would be PbI2. Our reaction PbNO32 reacts with NaI to produce PbI2. That's our solid. Remember, you really only have to write physical state if it's anything other than AQ. So all of these are AQ except for the lead iodide. And then we'll balance it. We'll put a 2 there and a 2 there to balance. And then C and D, your given is in grams and they want moles, and your given is in grams and they want moles. So go ahead and pause, work these out, and then come back and check your work. The answer for C is 1.51 moles, and that is of the NaI. And for part D, you get 0.607 moles, and that's of the NaI. Okay, so this was nothing new, moles to mole, mass to mole, and mole to mass. If these were difficult, you're going to want to go back and try them again before you move on to the next step, which is on the back of the worksheet, which is going to be mass to mass. So these, your bridges get longer, basically because you're not just doing mole to mole or mole to mass. You're going all the way from mass of one substance to mass of another substance. And anytime you change substances, The only thing that will connect them is moles. So you have to use the mole ratio to go from one substance to the next. The reason these are longer is because you're not given moles, you're given grams, which means you have that additional step of changing them to moles using their molar mass. So I'm going to go through and do the odds on the back side of this, tell you the answers for the evens, and then if you have difficulty, you can kind of go back and try to see where you went wrong when I do the screencast with the answer key. All right, so for number 1, it says 20 grams of zinc, so that's just Zn, reacts with excess hydrochloric acid, and so that's HCl, to produce ZnCl2, and they don't tell us what else. So if I look at this reaction, the zinc came and kicked out the hydrogen and bonded with the Cl, which means hydrogen is all by himself, but of course hydrogen is never alone because he's a diatomic. So then we come in and we balance it, we've got 2, and I think that does it. Alright, so the given is, it says 20 grams of zinc, and it tells me an excess of this. Be happy when you see that excess, because we're about to do limiting problems, which means they'll give you 2 amounts of reactants and you have to figure out which one runs out. So that just means we have plenty of HCl and you don't have to worry about it. They want to know how many grams of zinc chloride would be formed. Okay, so this is what I was talking about. You're going from grams of one substance to grams of another substance. We know that all these guys have different molar masses, so I can't compare them gram to gram. The coefficients, the 1 to 2 to 1 to 1, stand for moles. So if I can get this into moles of zinc, then I could go from moles of zinc to moles of zinc chloride. And then if I've got moles of zinc chloride, it's just one additional step using its molar mass. Alright, so we'll start with our given 20 grams of zinc. Grams of zinc is up top, so grams of zinc is going to go down, and our whole goal was to get it into moles so that I could switch from this substance to this substance. The only way I can do it is if they're in moles. So the molar mass for zinc is 65.4 grams if we have 1 mole. Now that I've got moles of zinc needs to go down. I'm trying to get to moles of zinc chloride. Well, looking at the balanced chemical equation, their relationship is 1 to 1. For every 1 mole of this, you're going to make 1 mole of that. So we put in 1 to 1. The last step is to get this guy into grams. So 1 mole of ZnCl2, I need to find his molar mass. So I do that by going to the periodic table. Zinc is 65.4 plus 2 chlorines is 71. So the total mass for a mole of this substance is 136.4. So here's my bridge, 20 times 1 times 1 times 136.4 divided by 65.4. Final answer with 3 sig figs comes out to 41.7 grams. And that is your zinc chloride. So really just one additional step. The key is do not forget your mole to mole ratio. It wouldn't have mattered in this one mathematically, right, because it's 1 to 1. But from a chemistry perspective, super important. The only way you can switch is to go through the mole ratio. Alright, so number 3, how many grams of copper are required to replace or displace 4 grams of silver nitrate, so AgNO3, which is in water. So don't be really distracted by that. That's just telling you that this is aqueous and you're adding some copper, and the copper is going to come kick out the silver. Now they tell you what happens, so you really don't have to check your activity series. But if we were doing this, start to finish, we would say, well, is copper higher than silver on the activity series so it can kick it out? The answer is yes. So silver now is all alone, and the copper is going to bond with the NO3. Now copper has 2 charges. It could be copper 1 or copper 2. We're going to treat it as copper 2 for this one, just to make it a little bit more exciting, balancing-wise. So if the copper's plus 2 and the nitrate's minus 1, this makes CuNO3 2. And then we've got to come in and balance it. Put a 2 there and a 2 there. Alright, so the question mark is grams of copper is needed to replace 4 grams of the silver nitrate. Alright, so my given is the 4 grams of AgNO3. This is in grams. The only way I can get to another substance is if I get this into moles. And so how do I do that? I've got to get the molar mass of the AgNO3. So grams are up top. We know grams has to go down, and we do moles of AgNO3. So I need to find the molar mass for 1 mole of AgNO3. You may be asking, well, why aren't you doing 2 moles since there's a 2 there? Remember, when we do molar masses, we want it per 1 mole, so that's a true statement. So there's 169.9 grams in 1 mole of this. If I put a 2 there, I'm going to have to double that number. And it's just silly. It's more math than we need to do. So always do your molar masses per 1 mole. We've got moles of AgNO3. Now I want to get back to moles of copper. Well, what's the relationship? Well, moles of AgNO3 is up top. For every 2 moles of AgNO3, it requires 1 mole of Cu. And then I need to keep going. I'm almost there. I've got moles of Cu. They want grams of Cu. So moles of Cu is going to go down. Grams is going to go up. And the true statement there, there's 63.5 grams of copper in 1 mole of copper. So the final answer on that one comes out to 0.747 grams of Cu. All right, we've got time for one more probably, so we'll do number 5. It says, how many moles of hydrogen can be produced from 8.4 grams of aluminum and excess sodium hydroxide? Okay, this one is actually a mole to mass, which is what we were doing on the front, right? So I'm actually going to leave this one and skip down. Let's see if we can do 7 together. The answer on number 5 is going to be 0.467 moles, and then the follow-up question is 0.93 grams. Those are both of hydrogen. See if you can get those. All right, so number 7, calculate the number of grams of oxygen that could be produced by heating 9.70 grams of potassium chlorate. So they want the grams of O2. They've given me the skeleton equation. It's a decomposition reaction. It's actually one that you should know how to do. It's a metal chlorate, and we know metal chlorates break down into a salt and oxygen. If I come in and I balance it, I've got a 2, a 2, and a 3 there. All right, so my given is 9.70 grams of KClO3. I'm trying to get to grams of a different substance. So I've got to get the grams into moles. So grams to mole of KClO3. Where does this conversion factor come from? Got to get it from the periodic table, the mass of K, the mass of Cl, and the mass of 3 oxygen. That comes out to 122.6 grams. All right, so we've got moles of KClO3. I'm trying to get from that to that. The only thing that connects them is their coefficients and their mole ratios. So I have 2 moles of KClO3 required to produce 3 moles of O2. In the last step, they want to know, well, what is the mass of that? Well, 1 mole of O2 has a mass of 32 grams. So here's our bridge. Multiply and divide everything out. Final answer comes out to 3.80 grams of O2. All right, so if you want to pause and go back and try the evens, I'm going to give you the answers for those so that you can check your work. So for number 2, the balanced chemical equation is Cl2 plus 2NaI yields 2NaCl plus I2, and the answer comes out to 6.07 grams of Cl2. For number 4, your balanced chemical equation is H2SO4 plus 2NaCl yields 2HCl plus Na2SO4. Final answer on this one is 18.7 grams of HCl. Number 6 balances 3, 2 yields 1, 6. And final answer on that one is 0.909 moles of CaCl2. Now again, this one was actually a gram to mole, so make sure you stop where they want you to. This worksheet said mass to mass at the top, but here they wanted you to stop at moles. All right, hopefully that went well. Check your work. If you missed any of these, go back, try to work them out, see what went wrong, and then I'll be sending the answer key out in a separate screencast.